Good morning, everyone, and welcome. We're going to get into chapter 1.2, section on Introduction to Calculus, the slope of a tangent line and a normal line. I want to just quickly show you the content lesson, though, from the D2L class. It starts with a review of straight lines, and I'm not going to go through that on the video lesson here. But what I want you to do is open Desmos and get some practice with Desmos. There's an explanation here and a link. I want you to understand how we write straight line equations of straight lines. That's in the form y equals mx plus b. The textbook solutions write it in Cartesian form. That's capital AX plus BY plus C equals 0. And we need to make sure that we can go back and forth between these two things. I want you to practice in Desmos, if you've never done this before, graphing the following 6 lines. And understand that a couple of them are parallel, but those are lines A, D, and E, and they're parallel because they share the same slope of m equals 3. Often we rearrange an equation in order to find the slope right here. This is what I did with E. And then I also want you to see that lines B and C are perpendicular, and you'll see that on the graph. But the perpendicular concept of a thing called a normal line. A line is normal to another one if they're perpendicular to one another. And by the way of the slope, that's a negative reciprocal. So if I have a slope of one line being -5, okay, and I think I should edit this. One of them is going to have to be a positive 1/5 here, or positive here. Negative reciprocal is what I have to do, and I'm going to edit this to see that that's the case here. So this is how we find the slope of a line, and then we go into parallel lines. And perpendicular lines, tangent lines, and normal lines. So that's what we're going to be doing here when we get into the lesson and we'll quickly review the lesson. So I want to get started. Okay, and talk about the slope-intercept form, y equals mx plus b. And I like using y equals mx plus b because it gives us a whole lot more information about the line. This is the slope, and this is the y-intercept. Okay, parallel and perpendicular lines. The slope of two parallel lines are equal, so they have a common m value. The slope of perpendicular lines are negative reciprocals. Okay, so let's state the slope of, and the perpendicular lines from a tangent line are called a normal. Okay, so if we can find the normal, the equation of a normal line, then we can find a perpendicular to it by changing around the slope here. So this is what I have to do, when I have an equation in Cartesian form. So this would be, in Cartesian form, this would be the line 3x plus 4y minus 12 equals 0. And that would be our A coefficient, our B coefficient, and our C coefficient. Okay, so let's find the slope of this line. Okay, so what do I do here? I rearrange it. So I need to, move my negative 3x term over to the other side of my equation. And then I have to divide by both sides by 4. That's this term by 4, and that's 12 by 4. Well, I can simplify that further. Can't simplify the slope, but it's okay if we have slopes as rationals here. That tells us a whole lot more. Okay, because I go down 3 and over 4, right? That negative 3 over 4 slope is a negative 3 rise. We're going down 3 and then going over 4. Okay, so my slope is right here, right? So when it's in this form, and I could call that the slope of my tangent line. That's negative 3 over 4. Okay, now if I can clearly state, that slope, I can do the negative reciprocal to find the slope of the normal. I'm going to call that small letter m for slope, and capital N subscript for normal. And I take the negative reciprocal, okay? So I have to take, the negative of negative 3/4, and I flip it to take the reciprocal, okay? I just state that. So if I have the slope of the normal, I can find the slope of my perpendicular. Sorry, if I have the slope of the tangent, I can find the slope of my perpendicular. Now, at this stage, I usually let people know, this very important concept of normals and tangent slopes. The product is always -1, right? So the product of a tangent slope and a normal slope is always -1 here. Okay. Okay, slope of a tangent. Okay, we find the slope of the tangent by going through, okay, what we did in the last section here, and that's finding the limit, okay, as q approaches p, okay, or as that gap gets narrower and narrower, and I can do, okay, that kind of thing here with a variety of different formulas. We saw these in the last little while. I can say the slope of my tangent, okay, is limit as h approaches 0, and this is going to be the common formula that we're going to use most in this class. Okay, that's how I find the slope of my tangent, as we did in the last little section here. Okay, so let's do this. Let's do an example here. Okay, so I want to find the slope of the tangent line, okay, of my parabola, okay, at this point. Okay. Okay, so I need the slope of my tangent line. Okay, and I'm going to do that, okay, by finding this limit. Okay, now I can, sorry, pardon me, substitute x equals 3 into this equation if I want to, or I can work it out. Okay, apply my function and just work it out and substitute at the end. I'm going to do that just for an alternative way to do this here. Okay, so let's apply my function. What's my function mapping telling me to do? Y equals x squared. Okay, so I'm going to take x plus h and square it, apply my function. Okay, my mapping of it. Okay, so whatever variable, well, as soon as I apply my function to it, I have to square it. Okay, and then I've got x squared over h. Okay, let's keep going here. Let's expand. X plus h quantity squared. That's x squared plus 2xh plus h squared minus x squared, okay, all over h. Okay, now I can, okay, simplify even further. This begins to look a lot familiar, very familiar to what we were doing in the previous section here. So we had numbers, more numbers in here. We're just working in two variables here. Looks like my x squareds cancel each other out. Okay, so I'm going to have 2xh plus h squared. Okay, they're going to cancel. Okay, now I factor. Okay, the steps are always the same when we deal with finding the slopes of tangents using limits here. We always, okay, apply the function, okay, expand and simplify, factor out the h. Okay, that will cancel, and then I've got my limit expression simplified down to 2x plus h. Now I actually, okay, I don't have a common 0, I don't have a 0 in the denominator, so I can apply h equals 0, so I can actually apply my limit. I can drop the limit at this stage and write my expression as 2x, but wherever there's an h, I'm going to substitute in 0, so that's 2x. And that's the slope of my tangent line. Okay, but here's when I wanted to then put in, okay, my point. Okay, and in this case it's x equals 3. So my slope of my tangent, okay, I'm going to say at x equals 3, it carries a value of 6. Okay, that's exactly how I would do that. Okay, and I might want to put a sentence here. Okay, the slope of the tangent line at 0.39, okay, of the function is 6. Okay, easy enough? Maybe. We'll practice this, okay? We'll, okay, see how it goes. That's the formula I was using, okay? This was the formula I was using, okay? And this formula here. Remember, the slope of a tangent line is still delta y over delta x, but I'm focused on one point, and this visual and this, okay, this graphic may help you work with that and see that. Okay, so let's, okay, see if I can work on this example. I just have to find this in my notes. Okay, so use the definition of the slope of the tangent to determine the slope of the tangent to the curve at the point by x equals 3. Okay, and then determine the equation of the tangent. Okay, and then sketch the graph. Okay, and I'll do that with Desmos here. Okay, so let's use the definition of the slope of the tangent for A here. Okay, so I'm going to, okay, I haven't done this one, so I'm going to, okay, maybe slowly go through this here. So, okay, so let's apply the function. Okay, so I've got the limit as h approaches 0, and my function is going to be negative x, I'm going to replace that with x plus h, quantity squared, plus 4 x plus h, plus 1, and then minus, and I'm going to put in, okay, my f at x. Okay, so that's going to be minus x squared plus 4x plus 1. And I'm going to make sure I try and do this working with two variables and not put in my value quite yet. Okay, so this is going to take a minute to expand this out here. Okay, so I've got negative x squared plus 2xh plus h squared, close my bracket, plus 4x plus 4h plus 1, and then I'm going to take away, let's close this bracket, I'm going to take away, okay, that's going to be a plus x squared, it's going to be a minus 4x, and a minus 1 here, and that's all going to be over h. Alright, this is complicated. This is a large expression. I think we can work with it. I have a negative x squared, a negative 2xh, negative h squared, okay, plus 4x, plus 4h, plus 1, plus x squared, minus 4x, minus 1. A lot of this is going to simplify. All my constant terms and all my x terms here. I'm just going to be left with h's that I can factor. Okay, so let's see if we can collect this. That one's gone. Okay, my 4x and my negative 4x, my plus 1 and my 1. And that leaves me with the limit as h approaches 0 of negative 2xh minus h squared plus 4h. That's it. Oh, okay, it wasn't so hard. Now I can factor h of negative 2x, okay, minus h plus 4, cancel, cancel, limit as h approaches 0, negative 2x minus h plus 4. And now I can substitute h equals 0 in here. I'm going to have negative 2x plus 4. And that's the limit, the slope of my tangent line. Is that what I was asked to do? So the definition determine the slope of the tangent to the curve at the point. At the point, okay, is when I have to plug in this. Okay, so the slope actually carries a value. It looks like it's negative 6 plus 4, okay, or negative 2. Okay. Okay, so now we've got, now we've got, determine the equation of the tangent line. Okay, so now I've got a slope of negative 2, and my point, okay, I need to find my y value of my point, so I need to evaluate f at 3. That was, okay, negative 3 squared, and I think it was a plus 4x. And that works out to be, okay, that's negative 9 plus 12 plus 1. Negative 9 plus 12 is positive 3, plus 1 is 4. Okay, so our point here is 3 and 4. Okay, so that's enough to find the equation of my tangent line. I can substitute the point 3, 4. Okay, my slope is negative 2. My x is 3 plus b. I have to solve for b. Okay. So my equation of my tangent line, okay, is y equals negative 2x plus 10. Okay, so I'm going to just pause this. I will actually pause it and go into Desmos and do this. Okay, so let me just simply pause this for a second and open up Desmos. Okay, there's my original function. Okay, y equals negative x squared plus 4x. I plotted my point here. If you don't know how to plot points on Desmos, you can do that. Okay, you just type in the ordered pair 3, 4. If you want to label it, you can on your graph. Okay, and you have a wrench tool here to make it a little bit larger. Okay, if you want, you can see that. Okay, and then I graph my tangent line in green. Negative 2x plus 10 is what I found that to be here. So that's all confirmed. That's kind of what it looks like here. Okay, let's continue with the rest of the lesson here. Oh, here's the graph. I forgot about that. I used an older graphing app, WinPlot it was called, from a number of years ago, but Desmos is the way to go now. Okay, let's do this one. Okay, find the slope of the tangent at the point negative 2, negative 8 for the function here. All right, so let's... I like to do it this way. Okay, I like to develop my x plus h expression. Okay, but if you like to put the negative 2 in here, okay, you can do that. Okay, that would be just fine here if we wanted to do that. Okay, just going to get rid of. Okay, so now I'm just going to return to. Okay, I think this is good practice though. So x plus h has to be raised to the power of 3, and now in the last homework, last section of the homework, I reviewed really quickly binomial expansion, so x plus h to the power of 3. You can expand this out the long way, okay, but the binomial expansion uses the coefficients are from Pascal's triangle, okay, and it really helps. It saves a lot of time if you just know how to expand this expression here, and then I've got a plus h to the power of 3 minus x to the power of 3 all over h. Okay, let's do this quick. Ding, ding. Okay, and I'm also going to factor out an h. Plus 3xh plus h squared. Okay, and I factored out an h in order to simplify. Okay, and then I've got this limit. Okay, and then I've got, I can drop that, okay, and just have, 3x squared, because that's will be 0, not 0. Okay, and I want to evaluate it at the point negative 2, 8. Okay, so my actual m value of my tangent line is 3, negative 2, okay, or what's that, 12? So the slope of my tangent is 12 here. Now state the equation of this tangent line. I found the slope, and I know my point here. I think I was given my point. Yeah, negative 2, negative 8. Okay, so I just put this into y equals mx plus b. You guys may want to get in the habit of pausing this and doing this yourself. Okay, I'll give you a second to pause it, and then I'll continue with it as well here. Okay. Okay, so the negative 8 goes in here. The 12, the negative 2 plus b, and I have to solve for b. Okay, negative 8 plus 24. Negative 8 plus 24 is 16. Okay, so my value of b is 16. And I just go and put that back in to my y equals mx plus b line, and that's the equation of my tangent line. Okay, normal lines. Okay, we talked about normal lines, and I have to go back and edit that page here. Okay, so consider the function. Again, we go through, we find the slope. Okay, and when we want to find the equation of the normal line, we just flip it and make it negative reciprocal. Okay, that's not a problem. Okay, so the same, okay, I think it was the same question. Okay, determine the equation of the normal line. So I think, okay, from last question, we found the slope of the tangent. What was it, 12? 12. Okay, so that's like 12 over 1. Okay, and I can just simply go through the process here. So the slope of my normal, okay, is negative 1/12. Okay, and I'm still going to use the point because the point didn't change, nor did the function change. Okay, so now I just go through the y equals mx plus b thing again, but with a different slope. Okay, so y equals negative 8. My slope is negative 1/12. My x value is negative 2, and I have to solve for b here. So that'll be 2 over 12 plus b, negative 8. Okay, 2 over 12 is 1/6. Okay, so I'm just going to change that to negative 1/6 over b. I need a common denominator here. So it'll be negative 48 over 6. Take away 1/6 equals b. Just want to confirm my solution. So I've got a negative 49 over 6 equals b. So my equation of my normal line, okay, will be y equals mx plus b. Okay, now that's ugly and sloppy. Okay, often we multiply everything by, let's multiply everything by 12. Okay, that'll make that negative x. Okay, and that'll make that negative 98. Okay, and then I can bring, okay, everything over x. Okay, negative x over on the left hand side becomes positive x plus 12y plus 98 equals 0. And this is the Cartesian form. And remember, I cautioned you that often the textbook will write their answers like this, and you might just have to do a little bit of a rearrangement, okay, of your answer or the textbook answer to confirm that you got the correct solution. Okay, there are some homework questions, okay, in here. You may want to try a few others. Let me just grab the textbook and see. You may want to try a few others. Determine the equation, determine the slope of the tangent line. So in 11, there's a few others you can do. Okay, in 10, you can determine the slope of the tangent. Okay, and then equations of tangents. Okay, that might get you rolling on this. Okay. I don't know. I've got a few more slides here. I've got some practice questions here if you want. I didn't assign this sheet, but again, if you're interested in, just let me know and I can get it to you. And then there's some review, mid-chapter review. We'll worry about this a little bit later. I guess this isn't part of, this is way down in the end of the chapter here, but we won't worry about that right away. Okay, in the live video lesson for the day, please make sure you work on this and ask questions if you have any. Thanks and good luck.